Hello friends, today I am going to discuss about the motion of the body in an inclined plane. It is very important in case of a student and those who are just start the friction and also the motion under normal force and the motion of the body in a plane or inclined plane. So I am going to discuss very briefly about the motion of the body in an inclined plane. So let's take uh, let's take a inclined plane like this. Okay. And this is theta, is the angle of inclined plane. And we consider a body here of mass m. Okay. So now, what happened? The weight of the body actually working downward, which is equal to mg. Now, if you just draw the reaction on the body, is which is r, and this angle is theta geometrically. Now, we can resolve mg into components. One is along the inclined plane, which is mg sine theta, and this is equal to mg cos theta. So this is the cases. So these are the forces which is acting on the body. So if you just compare, then R will be the mg cos theta, as you see from the figure, and the force responsible for the downward movement of the body is mg sine theta. So, if you consider F equal to ma, which is the acceleration, and then this will be m sine theta. So, will get cancelled out, and then A equal to simply g sine theta. So, this is the very simple case where the body is uh, moving under a smooth inclined plane with an angle theta. Now, this will change if we consider the frictional force. Suppose, say, uh, the friction between the two body is mu, coefficient of friction. In that case, as the body is moving along downward, there is another force which is acting upwards. And this force will be, as you know, the frictional force is always equal to the mu times r. That is the mu r. So in this case, we need to consider the effective force, which is different from the previous case, which is equal to E effective. And E effective will be simply mg sine theta minus of mu r. So mg sine theta is simply like this, and mu of r is mg cos theta. So if you taken out the mg, then this will be sine theta minus of mu cos theta. So now again, this is ma effective, that is the effective acceleration of the body. So m will get cancelled out. So simply a effective is g of sine theta minus of mu cos theta. Okay. Now, this is the case where the body is moving downward. That means mg sine theta is greater than mu r. Now, if you think that mu r is greater than mg sine theta, then the body will not move. Now, if you push the body up the plane, so the case will be the different, which I will discuss in the next slide. Thank you. Now we consider another case where we just like to calculate the force just required to pull a body up the inclined plane or down the inclined plane. For this, we actually consider a very simple diagram. Uh, say this is the inclined plane, and as per our previous discussion, we just resolute the different forces acting here. So, as the body mass is mg, so the mg is acting downward, and this is is mg sine theta, and this component will be mg cos theta, as you know, and a reaction is acting upward. So this is the reaction. Now we consider a force P here. And this P, suppose say acting an angle alpha with the inclined plane. And as the body is pulled up, so obviously the force of friction acting downward. So now we just resolve the different component of the forces. Here we can compare f of cos of alpha will be equal to mg sine theta acting downward, and F, which is the frictional force, and frictional force is obviously mu of R. So this is P cos alpha equal to mg sine theta plus mu of R. Now what is R? R is, mg cos theta, and minus of P of sine. So this is the equation number one, and this is the equation number two, and now we can put equation number two in equation number one. So the equation number one is simply like this: P of cos of alpha is equal to mg sine of theta minus, and this plus mu of R. R is simply mg cos theta minus of P sine alpha. So we just rearrange these things and taken out phi. P will be cos of alpha, and here it is mu sine alpha is equal to mg sine of theta plus mu mg cos of theta. So P is simply mg can be taken out, and a sine of theta and plus of mu cos of theta divided by cos of alpha plus mu of sine alpha. Now we can rearrange these things using the fact that mu is simply tan of lambda. Tan of lambda, not alpha, tan of lambda. And this lambda is the angle of repose. We can write down like this. That is mg sine of theta. And mu is tan of lambda and cos of theta divided by cos of alpha, and mu is tan of lambda actually, and sine of alpha. So these are the things. So we just put a mu as tan of lambda. Lambda is angle of repose. That means the angle at which the body just start moving. So now we are taking another new slide where we can actually simplify the equation, this equation. Okay. So this equation. So for this, we just write down like this: P equal to sine theta plus tan lambda cos theta mg sine of theta tan of lambda cos of theta, and cos alpha tan lambda sine cos theta tan lambda sine theta. So this is equal to mg, and if you just write down tan lambda as sine lambda by cos lambda, so this equation will be theta plus of lambda sine a plus b formula. And now for this also, cos theta cos lambda lambda sine theta. So this will be cos of theta minus of lambda. Okay. So this is simple equation. So now to P be minimum, that is the minimum force required to pull the body up, cos of theta minus lambda is maximum. So maximum value of cos theta is 1, and this will be cos 0. So theta minus of lambda is equal to 0. That is theta equal to lambda. So using this condition, we can write down the P minimum, that is the minimum force required to pull the body up, is equal to sine of theta plus of lambda. Thank you. We will discuss the next slide about the minimum force required to push the body down the plane. Thank you. Now let's talk about the minimum force required to push the body down the inclined plane. So we need to take another inclined plane like previous one, and just this is the angle of theta. And suppose say this is the body of mass m. So the force is acting here is mg, and this angle is theta. So again, this will be mg cos theta, and this angle is mg sine theta as previous one. Now we push the body down the inclined plane. Okay. So say this angle is P, making an angle alpha here. Okay. And this is the reaction. But here the catch is the force of friction acting upward. So mu r. So if you compare this equation, this is simply mu r equal to E of cos of theta and mg sine theta, not cos theta, be cos of alpha, and this is equal to theta. And r will be simply mg cos of theta minus of E sine alpha. So after rearranging these two equation, we will get again the P is equal to mg sine of lambda minus of alpha divided by cos of theta minus of lambda. So again, for minimum P, that is P minimum, we can consider cos of theta minus of lambda is equal to 1. So simply theta equal to lambda. So in that case, the P will be mg sine of lambda minus of, so P minimum. So these are the two cases where we can calculate very easily the minimum force required to just pull the body up or down the inclined plane. Similarly, we can take another example. For this, we consider another case. Suppose say here is an inclined plane and the body is here, m, and the force of friction says mu. So again, we resolve these two component, and this is, angle is theta. So this is mg cos theta, and this is the reaction r, and this is mg sine theta. Now consider a case, you just give initial velocity of u to the body, and as the body moving upward, then obviously frictional force acting downward. Say this frictional force is Fc, and after attaining certain distance, the velocity of the body will get 0. So this is the situation. We need to calculate the distance through which the body will move up the inclined plane. So as the for previous one, we just like to calculate the effective force on the body, if effective. So what will be the effective force? So mg sine theta as is acting downward, and here it is frictional force acting downward. So it is mu of r. So in this case, the mg sine of theta and mu r is mg cos theta. So this is like that. And if we calculate the A effective, which is simply, very simply, divided by F effective by M, so the G of sine of theta plus of mu of cos theta. So this is the acceleration, or we can say the deceleration of the body. So we can use the formula like this. Say v square equal to u square minus of 2as. Okay. So v will be the 0. So this is equal to u square minus of 2as. So s is the distance. So u square by 2a. Sorry, not 2g, 2a. So this is very simple. So use square and just paste effective acceleration here, and you will get the full distance at which the body will move. Okay, so this is the expression. So like that, you can solve the different problems involving the inclined plane just by resolving the different forces along the plane and the perpendicular to the plane. I think this discussion will help you a lot. Thank you very much for your patience. Thank you.